Hello and welcome back to the lab. Today on the bench we have an exceptionally rare Tektronix cover. Actually, we have a Tektronix 465, 485. This one is in incredibly good shape. A little bit of yellowing on the buttons. I believe, if I remember correctly, this is an early-ish serial number. This has some tape on it because finding these things without a crack in it is almost impossible. This is actually too big for my 3D printer. The Cetus won't print anything this big. I believe there's a printable version of this out on Thingiverse if you need one. But finding one without cracks is almost impossible, so the tape's kind of holding this one together. As far as I'm aware, this is the fastest scope that Tech made in the 400 series. So it's 350 megahertz, but to get there you have to use 50 ohm. It's got switchable inputs, 1 meg input and 50 ohm input. So the 1 meg I believe goes to 200 megahertz, and the 50 ohm goes all the way up to 350. We're going to go through this, restore it. If there's any problems with it, we're going to fix it. Given there's always going to be age-related issues with these unless you buy them completely rebuilt and almost at the price of what a new modern scope costs. So we'll crack this one open, get into it, check the power supply, check the filtering. I can't use the 7510, so I'll be using the 6500. 7510 is actually not in the lab at the moment. It's out getting calibrated. I have a video coming on that. It is off at Keithley getting calibrated now. So if everybody notices there's a hole right here where the 7510 usually sits, that's due to it just being back at the manufacturer undergoing calibration. So I will have to redo the attenuator, or clean the attenuators in here. I'm sure they have some age-related issues, but we'll get into that when I get into them. I've serviced a couple of these before, and the attenuators actually in these are a lot easier to deal with than the 465 and the 465B. So there's a module that pops out the bottom, and that's how the attenuators work, and there's just two cables that hook them up to the rest of the scope. Let's get into it. I'm going to get some gear warming up, and we will see what secrets the 485 holds. Okay, to get into a 485, these are the actual manufacturer feet that come with it. These screws pull off, and then there's a metal frame that comes out, and then it'll slide out the front like the rest of the 400 series. So I'll get these undone real quick, and then I'll bring you guys back. It should be noted that the screws in these feet are incredibly long. Okay, and with the feet removed, this metal frame just pops out. Let's see, we'll get everything off to the side where it's not going to fall into the operating scope. Be careful with things above the working area on a bench. Stuff loves to fall into powered on equipment, and that causes bad days in the lab. And here we are with the case off. So let's take a quick look around. This is trigger board, I believe. What do we have up top? So some horizontal and geometry. So horizontal, high voltage, and y-axis triggering. Here's x-axis actually right here. Here's x-axis. And what do we got on the bottom? Here are the attenuator modules that I was talking about. So these actually pop out pretty easy on this scope. And I'm seeing some capacitors that I want to change. Okay, we'll be doing some restoration work on this one. Down here, that looks like a mix of timing and power filtering. We got some pretty decent sized inductors down here too. do have some power supply capacitors in here that I'll probably want to change. Not really seeing bulk filters, so let me get this back cover off and we'll take a look and see what's in there. Well, taking the cover off on the side, we expose a couple of screw terminals. This is pretty heavy power supply section. Main rectifier, a couple of switching transistors, and a switching transformer. I don't know if this is linear or a switching supply. However, those giant bolts in there, those are probably hiding some pretty decently sized capacitors. So let's see what we can do about that. They really do not want you under this back cover. Let me show you what I found. So here's our main cooling fan. So that's all right. Line fuse is here. Back of the tube is here. This scope has been off and dead for months. I haven't even plugged it in before this video, so nothing to worry about in terms of voltages or anything like that. I can, looking through this hole, I can see the bottom of the two bulk filter capacitors. So I'm pretty sure this is going to be a switching supply. And I do want to check those capacitors as part of this repair, but I'm not quite sure how to get to them yet. So power supply board may need to come out. There's a couple of other ways that could be done. I should probably take the power supply board out anyway to clean it. But let me take some pictures and we'll get started. And after a short bit of disassembly, our inverter board is upside down. One thing to note is on these ceramic heat strips, on some of this older gear, this is beryllium. This is a beryllium-based ceramic. So you don't want to do any kind of sanding, any kind of anything on these. The dust from these, they're fine as long as they don't crack or sand or grind or anything like that. You do not want to be breathing the dust from these. So just be careful there. But here's our bulk filter capacitors. These things are massive. For this scope. They barely fit in this pocket, and there's not a lot of room to get those out of there. I'll show the reverse when I put it all back together of what you got to do to take it out of there. So what I'm going to do is I'm going to unbolt these, and then we'll give them a test on some of the gear I've got in the lab. If they're good, they'll go back. If they're not good, we'll replace them. I hope these are good. These are not going to be cheap capacitors. These are probably $25 to $30 a piece if I have to replace these. So I'm hoping these are fine. I don't mind replacing the smaller ones in the low voltage power supply, but these bulk inverter caps are not inexpensive. Also, if you disconnect something of this size, make absolutely sure you get the polarity right. If these things go, they're going to go with quite a bang. Well, these are not going to be fun to put back together. There was a washer on the top and bottom of the board protecting it from the posts of the capacitors, so I'm going to have to get those back in. So this is going to be kind of fiddly to put back together. Okay, so the first capacitor tested okay for leakage. I have to check the other one. Since I had 150 volts applied across this capacitor, I couldn't do the 200 volts because the IT28 does a little bit high because of the line voltage, so it would overvolt the capacitor, which I didn't want to do. So I topped it out at 150, but it checked out okay. This was the cap I tested. It's just got a jumper wire on it, and I'm using a plastic insulated tool as a pointer. This is just a safety factor because of dielectric absorption. I don't want to get blasted while I'm handling this other capacitor because I did put 150 volts across this, and these are pretty decently sized capacitors. So I'm going to start to test on cap number 2, and we'll see how it goes. All right, both filter caps tested good, so I have them both mounted back to the inverter board, and I'm getting ready to put the inverter board back into the scope. So I've cleaned these heat sinks a little bit just with some isopropyl alcohol, no big deal, and I'm about ready to set the inverter back into place. After the inverter's back into place, I'll go through it and I'll show you guys what it took to get this thing out of here. Okay, there's small screws around the perimeter. These little guys. The larger screws with the lock washers and washers are for the inverter transistors. And then the other screws are these, which are the supports for the cover, and they go in the sides here. So when I get to those, I'll let everybody know. So for right now, I'm going to put the small ones in. Okay, next up are the standoffs, and they latch into a slot that's in the case, and then the screw comes in from the outside. And zips in like that. Now, also one thing to note is a lot of Tektronix gear for whatever. Come on, focus. You can notice that this bit has a kind of an odd shape to it. It's not a Phillips. Most Tektronix gears actually posi drive. So if you're working on this stuff and you find you're blowing screws out, try a PZ bit, at least in the United States, and see if that helps. It should grab a bit better. Okay, if you're having intermittent goofy problems with a 485, first thing to check, these comb connectors. These are used extensively, and they will tarnish. They're gold plated and everything, but they'll still pull a little bit, get a little bit of tarnish on them. And the sockets, make sure the sockets don't have cracked solder joints. Make sure the gold connectors are good and they're not tarnished. And they are everywhere. Just on this board, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of them. So they are used extensively in this scope. So if you're having goofy issues, check these. Also, if you ever take one out, make sure they actually seat all the way and mate into the pins on the receiving board. This particular one that I just put in is the main interface between the inverter board and the low voltage power supply. So, very important. Okay, let's just check and make sure everything's all right. Drawing about 60 watts, which is normal. We have lights, which is good. See if we end up with a trace. And there's a trace. So, perfect. So our, is that a little bit of fuzz? Might have to address some of the plastic. We'll see. But as of right now, scope is functioning, at least temporarily, till we take it apart again. Everything looks good. All right, next up we're going to turn our attention to the power supply section and get in here and replace some of the electrolytics because I want this to run trouble-free for quite some time. So these guys are all going to go. We'll get some capacitors out of the boxes and we'll get into switching these out. Well, of course, I get into doing a restoration and I need some hookup wire and I need some capacitors. So I got to put in an order to DigiKey. But I have a good bit of, about halfway done on the low voltage power supply. I got all the combs back in. So we're going to do a power on and make sure everything still works. Intermediate testing. 60 watts, that's good. Let's see if we get a trace. There's the trace. So the scope is still very healthy. No problems there. And everything looks good. We're drawing about 50 watts on the AC line, so no problems whatsoever. And everything's going really well. I need to get some smaller capacitors. I have some like 450 volts that'll fit, but the space that I'm working in is pretty tight, and I don't like how big the capacitors are, so I'm going to get some smaller ones. And I'm also going to run some testing on the attenuator boards. Lots of things in process, but through the magic of the camera, I will have to wait on the mail. You guys, I'll just be back. Okay, I have the unit plugged in, and the power supply has been rebuilt. All the caps in the back have been changed, and no smoke. All right, we're drawing 60 watts, 59, which is about normal. Give it some intensity. Yeah, we have a trace down on the bottom and no smoke. So I'm going to let this burn in for a while just to make sure nothing overheats, gets dumb, or does anything foolish. So I'm going to just leave this open for tonight and let it burn in. And tomorrow I will attack the attenuators. I want to get these cleaned up before I start doing an alignment on the scope and get everything back the way it should be. So progress is being made, slow, but these were the 3 caps that I ordered, or the 3 sets that I needed that the lab didn't have. They came in this afternoon, so we are good, and we'll leave it at that. Okay, I've gotten I'm getting ready to pull the attenuators out to service them. The front controls have been removed. We'll lock those back just so they're easier to deal with. I gotta pull these push buttons off, or these toggle switches off. There we go. Now, when the attenuator is removed and I'm servicing them, that's a great time to service these switches, and these switches, because these actually come all the way back into the unit. So to get the attenuators out from this point, I have to take this nut off the front panel, and then there's a couple screws that hold them to the frame, and then they actually just lift out. The nice thing about the attenuators is there's just 2 wires that connect them to the unit. Kind of fiddly to pull in and out, but not too bad. So let me finish undoing some screws, and we'll get some attenuators out. To do the alignment too, you'll notice there's a 1x, 10x, and 100x LEDs on the 485. I line up with the highest value, so when I put the knob back on, 500 goes over here. Just the way I do it. Seems to work out okay. And here's the back of the unit open. Each one's a wiring harness for one of the attenuators. So you have 2 plugs and one of the Tektronix micro coaxes that need to come out. Channel 2's on this side, channel 1 is on this side. Here are the attenuator sections for 485. They actually come as these modules, so they're real easy to replace. I'm assuming this was done for serviceability, but if these were purchasable, they'd be real easy. You just swap in a new one, do a little bit of a calibration, and off to the races. Of course, Tektronix never designed this long a lifespan into these attenuators, so they are handed. I should mention that. The only thing that's different is this screw right here in the back. There's a wing here that goes back there and supports these to one of the switch stacks. So these attenuators are handed, but it's not too bad. But I'm going to have to tear one of these down completely, and I'll show you what's inside these shielded cans. Alright, and here's the inside of one of those 300 megahertz attenuators, 350 megahertz attenuators. So there is a lot going on in here. We even have some application ICs in here as well. There's that I believe is the 50 ohm resistor. We have a micro relay down here. So I think this is the 50 ohm resistor. So what I got to do is I actually have to get further into this to service all the micro switches. So there's micro switches on top, micro switches on the bottom, micro switches on top, and micro switches on the bottom, all driven off the one drum. So there's a lot to do in here. Let me get these boards split apart, and I'll see if we can get a better view. Okay, well, after taking a dizzying amount of screws out, I finally got the board separated. This one also has 2 micro coaxes here and a harmonica connector here that interface with the bottom board. So this is as far down as I think I need to tear it to clean the contacts of the switches. So we're going to go ahead and clean the contacts of the switches, get everything reassembled, do the same treatment to the other attenuator, get everything reassembled, pop them back in the scope, and make sure all the ranges work and nothing happened. After that, we will see what else the scope needs. Attenuators are back together, ready to go back in the scope. So I just got to get these shoehorned back in. One of the connectors is here, and then there is a micro coax connector right there. So you have wiring harness, micro coax, and then they just bolt in very quickly. So I'm going to get those tossed back in, and then we'll fire it up. All right, I'm hooked up to the calibration generator. We're on 5 millivolts per division. I am shooting 20 millivolts of signal into the front end. Obviously, we are off a touch on calibration. Not by much. Let's see. Yeah, it needs to be calibrated because that's 4%. That's actually 4% low, so just out of spec, but we're at its lowest range, so we'll kick it up. And let's see what we've got for... Oh, the power supply just failed. What just happened? Well, after doing some ohmic resistance measurements of the power supply, my plus 25 volt rail is 6 ohms. So that's going to be a problem. So I have a problem in the 25 volt rail. Okay, after doing some voltage injection on the 25 volt rail, I found out this resistor was getting a little hot, and that led me down to this tantalum capacitor right here. This cap is dead shorted, so it will have to go, and so I'll get that replaced, and then we'll continue with troubleshooting. Here's the resistor and the capacitor that I ended up replacing. This is the resistor that dissipated a little bit too much power during the voltage injection, and which led me to the shorted capacitor. So the good news is it's all right. It still measures like a 4 ohm resistor. It's a 5.1 precision resistor. This cap is turned into a jumper, so it has been replaced. I did do a check of the power supply when it was running with the capacitor out of circuit, and it only was a 20. It's a 35 volt cap, but it's a 26 volt circuit, so it's within voltage tolerance. So it just decided to go. Yeah, so let's fire the scope up and see what it does. Okay, hopefully we are out of click mode. Well, that looks better already. We'll turn the illumination down. Let's put some signal through into it. Clean it up because I have the lab's very noisy environment. So what you're actually seeing, the glitches here, that's not the scope. That's just triggering on some high frequency noise, because if I put it to high frequency reject, it cleans up, it stabilizes the waveform. So everything's working as to be expected. I think I'm ready to calibrate the scope again. Let's see. Let's actually check this other range, this 10 millivolt range. If it's 4.5% low, 4.1% low, that's a good sign if all of them are that way, that it just needs an alignment. It's a little light at 4.1, probably so 4.2, so probably going to be good with an alignment at this point. Before I go through the process of doing an alignment and getting everything all tuned up, I'm going to let this run for a couple of hours again just to see if any more of those capacitors decide to become resistors. Hopefully it doesn't go back into click mode. If it does, we'll keep addressing it until it's fixed. The new capacitor that went in, it was a 6.8 microfarad cap at 35 volts on a 25 volt rail that went in. Replace that with a 10 microfarad at 100 volts. So that cap will never die again. It's way overrated for voltage at this point. So yeah, we'll just let the scope cook and see what happens. I don't expect anything else to go south. So it's weird that one even decided to. I'm going to do some AC measurements on the voltage rails, just make sure we don't have a lot of ripple or anything like that, because I replaced all the capacitors while it's up and running. I don't expect there to be too much trouble. So we'll just let it burn for a while. Well, the 485 ran flawlessly all night. Not all night, but for about 7 hours, and no additional problems out of it. I can throw a waveform on it, and it'll display waveforms, it'll trigger, it'll do everything it's supposed to do. So the restoration is done. I now need to run it through a calibration routine and get it patched up and squared away. I looked at the calibration for the 485. It's actually quite a bit shorter than the calibration for a 465 or a 465B. So what I'm going to do is I'm going to cut the restoration video here, and I'm going to do an alignment. The next video that comes out is going to be an alignment video for the 485, and then we'll get into it. And then we'll see where else the lab takes us. So thanks for stopping by, and I will see everybody in the next video.